Wow, those are really cool. Hey, there's Eric. We have you on Channel 9 a lot. What's going on today?
Well, we're here with the C# team because we won some awards. So,
So it's that you won the Outstanding Technical Achievement Award
that's correct.
for Microsoft.
Yeah.
Congratulations, you guys.
Yeah.
So who are you?
So I'm Eric Meyer.
Sure, I'm Peter Hallam.
I'm Todd Probster. Anders Heilsberg.
Scott Wiltemuth.
And I'm Sean Katzenberger.
Excellent. So what does winning this award mean to you? I mean, like it's pretty prestigious to win an award like this. How do you guys feel? How's that for?
Well, it's always nice when you can bestow awards on yourself. But I mean, I think it's great. You know, I mean, I always say it's nice to win awards, but it's nice when the awards come from people you respect a lot. And this award is from the top technical community at Microsoft, which a lot of people there that I hold in high regard. So
Absolutely.
yeah.
Cool. So let's jump right in then and start talking about what you won the award for, C#, right? So, I mean, beginning with Anders, of course, let's talk briefly about why. Why C#? Why did you choose the C kind of syntax? Why, let's talk about that. And also the fact that you evolved sort of in parallel with the CLR. Without the CLR, there's no C#, et cetera, et cetera. So let's talk the history. Because we've had you on Channel 9 a lot talking about the future and stuff. But we can get into that a little bit. But let's talk about the history of C# with all you guys.
Well, the project got its official start in December of '98, or maybe it was January of '99. Back when it was called. I think our code name was Cool for C-like object-oriented language.
Safe C before that.
It was Safe C for a while.
No, the first
I think it was Cool first.
The first paper was that one paper which is titled "What is Cool."
What is Cool?
Oh.
Which is a very catchy name.
Which was like a little 4-page paper.
Right, and then we had this weird thing where for a while the code name leaked, and then the marketing denied that it was Cool was the code name. So we're going on the record today as saying that Cool was the original name.
Cool was the original, and you
Marketing
wanted to
guys
actually
did
keep
not.
it.
The rumors were right.
The rumors were correct.
The marketing didn't like it, huh? How could you not like a programming language called Cool?
Yeah.
So it sounds like it was C from the beginning. You said, all right, we're
Yeah.
going to do a C-based syntax from the beginning.
Yeah, that was just sort of an assumption. I mean, we already have a big community in Visual Basic with a certain syntax, and we were looking to build a language that would appeal to the curly braces crowd, if you will, on the new .NET platform. And by curly braces crowd, I mean anything from C++ to C to Java to, well, at that point we even had JavaScript, right? I mean, JavaScript. So yeah.
Excellent. So how did you guys come together to form this team? I mean,
That's a good question. We had some initial designers. We kind of drafted some key people who were experienced in designing languages, and so Anders and Peter Solich, Peter Kukl, and me. I'm not sure who else was in the original design meetings. Is that
Peter Goldie?
Goldie.
Well, yeah,
We had a lot of Peters.
Yeah, there were a lot of Peter
maybe you should have called him Peter. P#.
Peter was definitely one of the people involved in the first meeting. I think that was the core group, and then we evolved the group from there. And the group that we have here is essentially some of the key people, not all the key people, from C# 1.0 and 2.0. And so various of these other people were added at different times. So. And that it's basically evolved from there, and we have a current design working group that's working on C# 3.0.
Right. And Scott, at the time, actually, were you at the Genesis at the beginning? Were you in Hawaii, or
I was, yeah.
Scott was our long distance program manager. So he spent
From Hawaii?
from Hawaii.
Oh, rough.
Yeah.
Hanging out in Maui, like checking
So
your
we
email.
had-
That sounds like a good idea.
We still have our design meetings are still in the same room that we started in 7 years ago. every Monday, Wednesday, Friday afternoon. And in the beginning, we had this tiki that Scott had sent back from Hawaii that represented Scott. We would take out of the closet and put next to the speakerphone, and that was virtual Scott. You know.
And the theory was that if there was somebody to talk to, that people would be more likely to talk to me. But then they would have pulled out when I wasn't there, and there were kind of things that I said on a recurring basis that were like written on the tiki. So it's like people would be like, you know, representing Scott, I have to say that.
Oh, that's a slippery slope. A slippery slope. Yeah.
That's excellent. So let's talk a little bit about what is the design meeting like with you guys? I mean, what do you do? So let's talk about that.
Should ask someone else.
Well, that's a good question. Well, we get started about 10 minutes late.
On whole tradition.
You can pretty much set your clock by that. And you know, we get together. Usually we start with an agenda, and it usually goes on the whiteboard. And talk. Well, we just want to say agenda, but we just have a list of items that we want to start digging into, and that usually gets up on the whiteboard, and then and then we usually sometimes we start at the top, and sometimes we just start at whatever we start at and dig in.
Yeah, I must say that the C# design meetings are extremely effective. It's like the thing that I try to imitate in all the kind of other groups I'm involved in. First of all, they're extremely technical, so there's no kind of, you know, bullshitting about, you know, process or stuff like that. So it's very kind of, you know, for geeks, very pleasant.
Good.
The other thing is that, you know, the notes are really good. So I think the notes go also back to kind of way in the beginning. So that means that, you know, you never kind of run around in circles, because we can always kind of go back to the notes, or we say we do go in circles, but at least you can point at, you know, what we taught previously. So I think that's kind of, you know, it's a very good format for doing these kind of design meetings. And the other thing is also, because there's a lot of continuity, there's a context, right? There's memory. You don't have to. A lot of other meetings, you never make progress because it takes like half an hour to bring people up to speed. And I think here it's really good. You know, you can immediately start kind of, you know, diving into the technical details. So I think it's really fantastic. I've never seen this kind of meetings anywhere else.
Cool.
Yeah.
And I bet the debates are fun and can get
Oh,
quite
yes.
heated.
I
I'd love
think,
to see that.
You know, when you have the same, I've sat through, in the 10 years or 11 years I've been here, I've sat through a lot of meetings. And meetings have certain dynamics, you know, depending on, first of all, how large they are. And, you know, once meeting gets beyond like 7 or 8 people, then it turns into a lot of chest banging because everybody has to prove how smart they are to each other. But even that happens too in meetings. If you have meetings that are regularly scheduled and they just go on and on and on, and you get to a point where everybody knows each other, and you've got nothing to prove anymore. Everybody knows exactly what you do and what you don't do.
Yeah.
And everybody has the same context, and you can just walk in. You know, you had some brilliant idea in the shower that morning, and within 2 minutes, you can have a deep discussion about it. You know, and get valuable feedback or get the thumbs down, you know, and or whatever, you know, but you don't spend 50 minutes context setting or politicizing or whatever, and so it's a process that works.
And Anders really brought that dynamic to the C# design process. We'd used the same process for some previous products or projects, and it continues. So that kind of is spreading, I think, and Anders is really it takes somebody to kind of put the group, both kind of do the group dynamics of getting the right set of people together and then creating the right dynamic in the meeting, and that's really what Anders does.
Yeah, one of the interesting things about C# for me is, you know, the meetings, often there were new issues that had to be addressed, or there were old issues that had to be revisited based on feedback or whatever. But also the language is evolving, so there were often meetings about new issues. Somebody proposes something new that can be added to the language that'll, you know, satisfy some either customer group or
Like iterators.
like iterators. I'm speaking from personal experience.
Is this Mr. Iterator? Nice job, man.
So yeah, that's how I got involved. I sent email to Anders saying, "Hey, have you thought of putting clue-style iterators into C#?"
No, but I thought about putting you on the design team.
And so I said, "Come on, make your pitch." So
That's great. Well, thank you for doing that. I mean, things like the CCR, are very dependent upon iterators. Good job.
And all of Link, of course, is building on what we did in C# 2.0, which is very
Right,
cool.
right.
Between iterators and anonymous methods and generics. So it's neat to see that the 2.0 is feeding right into 3.0.
Yeah,
It's
yeah.
kinda
Yeah.
nice.
And even the same thing happened from 1.0 to 2.0. I remember as well. I remember giving some talks to some, and every time I was talking about the 2.0 stuff, when I first talked about the 1.0 stuff, it was like there was some decisions we made that were like, I know this is important, but I can't tell you why yet. And then once we actually, and
Trust me.
Yeah, and then once we got to 2.0, all the stuff was like, it was so much easier to talk about, unifying the type system in particular. It was just, once
Right.
it got to generics, that just, it becomes such an important issue.
Yeah.
Just think about the roles again. The other interesting thing is just there's sort of like, in the design meeting, there's different people play different roles, right? And we've always had someone sort of representing the academic community, and we've had someone representing. We've always had someone, at least someone representing, the implementation team, and and then someone, representing sort of program management as well, trying to figure out the schedules, of course,
Mhm.
and Anders, of course, setting direction. So it's been kind of interesting to sort of see how, sort of, when Todd left, we needed another academic. So that's where Eric came in.
So from one C# 1.0 to where you are right now, you guys look back and ask yourselves, like, what were we thinking? When you think back to the earlier stages, I mean, I'm not trying to present it in that way, but I mean, language has evolved. So when you think about 1.0 and where you are right now, there's a not dramatic, but a significant change in how productive people can be. Generics, an obvious thing, iterators, anonymous methods. So let's talk a little bit about that. Like, you haven't said very much over there. Now, I know that might not be a fair question, but
Yeah, I mean, as far as that goes, there's certainly things that we've gone back and said, gee, if we'd known what we know today, we would have done it differently. But at the same time, we just need to keep pushing forward, and so you can't play that game too much. I mean, for example, with Link, we look back at the anonymous syntax or anonymous method syntax we ended up with and said, maybe we should have brought it closer to the Lambda syntax
Yeah.
that's being introduced with Link, things like that. But all in all, I mean, I think we've put together a great language design, and the whole language design meeting format has just been proven very effective. And it was a real privilege to be involved in that. I've, of course, moved on since then.
So tell us a little about yourself. I mean, I'm sorry that I got sidetracked into the language.
Well, Scott and I
people.
go way back. Scott and I worked together on JScript, which is Microsoft's version of JavaScript, in the IE3 and IE4 days. And I left Microsoft in '98. And I don't know if Scott and Anders remember this, but in '99 they approached me and said, hey, how would you like to do some contract work on this new project? And I foolishly said no. So in 2002, I think it was, I contacted Scott again and said, hey, my wife's giving me permission to do some work for Microsoft again. And, do you have anything?
And I said, hey, would you like to do some contract work on this?
Yeah, exactly.
I said the exact same thing
The
4
same
years
thing.
later.
And Todd had just proposed iterators, and so my first assignment was to help, spec iterators and work through that with the design team. And I did that remotely a little bit from Maryland. And then after talking about it with my wife, she said, well, why don't we just move back? You go back to Microsoft. So I came back full time in 2002. And of course, participated in the design process for Whidbey C# 2.0, as well as implementing a substantial portion of the features for 2.0. And since Whidbey, I've moved on to a new incubation project that I can't talk about.
Of course not. We'll have to burn the tape. There is no tape, though. Very cool. So let's talk. I mean, you mentioned there, and we've had Anders and Eric on here before. We talked about Link and what that means in terms of the evolution of imperative languages and the dynamic age. So I would ask you guys, though, this question, because I've gotten this feedback from developers who use the language every day. And their question was regarding Link. They were kind of concerned about what that does to the purity of the language. So all of a sudden, you're now adding these dynamic constructs, and you're going to go even further, perhaps, in the future. And so how do you answer questions about, hey, you're messing with the purity of the language. I really like this language. I like imperative programming. I don't want to do database work. So you could say, well, then don't use Link. But let's talk about features and stuff versus purity?
I think purity is it's a loaded word, because what's bad about purity, right? What could possibly be bad about that? And it's like, well, purity in its ultimate form means no evolution whatsoever, right? Because the purest thing there is the first thing, or nothing for that matter is even pure, right? I mean, so you sort of have to have a pragmatic viewpoint about purity. There's purity, and then there's practicality. You know, the language has to help you be productive. I mean, at the end of the day, that's how you're measured, right? Did you get your application written sooner, faster, better, with fewer bugs, or whatever? So as language designers, we sort of have to think about, we know that every feature we add to the language adds weight and gravity and, if you will, unpurifies. So we have to proceed with caution, and I think, you know, it's that balance of being cautious about what you put in and being absolutely sure that because you know you only have so many bullets to fire, you know, before the language is it caves in under its own weight. Every language, you know, ultimately, if you're not careful, ages, right? And every feature ages the language, and you just have to be sure to not age it prematurely. And I personally think that we, with LINQ, have found ourselves sort of at a crossroads where we could actually sort of build a bridge between an imperative and a functional programming language and be, I would argue, the first to capture the best of both worlds, or at least part of the best of you know. And I think that is a phenomenal opportunity. And I really do think that yes, the bridge messes with the purity, but boy, it builds a bridge to a whole new green grass field, where traditionally line of business programmers, enterprise programmers have not really gone before. And so I think, you know, whatever impurity it adds, you know, it repays, you know, by where it goes.
We should talk about domain independence, I think, because like with LINQ, we're adding support for manipulating data, but we've done it in a way that we've been very careful not to kind of specifically tie ourselves to one of the domains, like we're not turning C# into Fox Pro or something like that. We're specifically about a database or even a domain, and so I think the approach that Anders and the rest of the team have taken in C# 3.0 is just fantastic. Of identifying the places where the language is not expressive enough, and therefore people end up going and inventing other languages like query languages for SQL or for XML. Kind of identifying those fundamental building blocks and building those into the language, and kind of thus increasing the toolkit of the people creating APIs, so that people creating APIs can build LINQ-enabled APIs, and then you get this fantastic economy of APIs where anybody can create them. And that there's nothing in the language that's specifically about any one of the domains. The concepts in there are all completely general, so that you can use any of the language features, or including things like the query comprehensions across any domain, an extensible set of domains specifically, and that's an incredibly both insightful and kind of deep innovation. I'm really proud of the team's work on that.
Absolutely.
So another thing there is that for C# Trio we didn't add anything new to the CLR. So, you know, we've just written a paper that we submitted to UPSLA, where we show, it's called Lost in Translation, that all the stuff that we add in C# Trio can be compiled away. So in some sense we're not kind of making the language more impure, because everything you can express in LINQ you could already express in C# 2.0, but much more verbose. So we've really made it kind of much easier to express things that you could already express in a much more concise way. So I think that's very powerful. So we've kind of formalized certain kind of design patterns, as you may say, and, you know, lifted them up into the language such that the compiler and the tools know about it. So I think that's, you know, and the nice thing, for example, with expression trees, that's kind of, you know, I think one of the most powerful things in C# Trio, where now people can really build, as Scott said, you know, kind of domain-specific APIs where you can take whole expression trees and give it to some processor that it can then interpret kind of complete programs. For example, if you have a GPU or other things like that, or like SQL, right, where you can execute it. But it's not, as Scott said, not limited to SQL or anything, but it's like now completely open. You can program kind of anything that kind of can accept some kind of, dynamic language that you can feed into it, or some program.
Understood. I mean, that's a great point, because I think something that people get confused of with LINQ is they kind of, for some reason, relate it to writing SQL statements.
Yes.
Select star from
Sure.
blah, blah, blah.
Yes.
Well,
where in
that's-
fact that's not the case. It's,
Exactly.
it's a general purpose.
Yeah.
Right, but that's I think that's one of the things that has been so hard for a lot of people to understand about, say, functional programming or domain specific or meta programming. Is that it's an abstract concept, right? And what we're hopefully succeeding in doing here is making that abstract concept very real. With some, solving a real world problem like query integration in a general purpose programming language. But the thing that's so wonderful about it is that that the abstractions are still there, and LINQ is just built out of 8 language features that in and of themselves add value and can be used for other things, which is always the hallmark of a good language feature. It's the fact that it isn't just for one thing. It is generally applicable, because we are a general purpose programming language. So it's always a little bit. One is always a little bit suspicious as a language designer if a feature is only good for one thing.
Agreed.
That's.
Plus, have you seen any interesting uses? I mean, I mentioned earlier about probably, in my opinion, one of the most interesting uses are just around the company, the coordination and currency runtime, their creative use of iterators, generics, blah, blah, blah. Incredible stuff, which solves a pretty high level concurrency problem. They have so much concurrency, they don't know what to do with it.
Mhm.
So, have you seen any interesting uses of the LINQ constructs, like the things that are actually used to make LINQ? People using.
Well, I thought the link to Amazon. There are third parties. A lot of third parties, just people in the community are experimenting with LINQ and playing with it. And so we've seen a number of existing object relational mapping systems where they're adding LINQ support, which is great to see.
Nice.
But then we've seen things that are kind of like more outside the mainstream, like LINQ to Amazon, where the things that you're expressing are all about getting books from Amazon.com or getting CDs and things like that, and it's incredibly expressive, and it's that kind of, when you see that kind of diversity in the things that are popping up in the community, then that you've kind of gotten some of the atoms and molecules that we're building into the language correct, because it means that people can go and build some of these more complex structures that you didn't conceive of at all when you started.
Excellent. So let's talk a little bit about what it means for, now that we're in the age of multi-core. Why is functional programming important? I mean,
Well,
why do we care about functional programming?
Well, I think it starts with just programming at sort of a higher level of abstraction. I think, and I think that's a big piece of it. Everything that we're doing with LINQ and sort of the evolution of language, from 1.0 to 2.0 to 3.0 has always been, giving the programmer the ability to sort of, program less about the details and more about the problem space. And I think that's.
Yeah, I think for the past like 40, 50 years, we've really sort of run on computer architectures that are. There's a very clear evolution, it's Moore's law has just run at its very constant pace and provided us faster CPUs and more memory capacity. But now we're sort of coming to a point where there is a fundamental change in Moore's law. It's not going to go away, but it's going to change in that it's not going to give us faster CPUs anymore. It's going to give us more CPUs. We're still putting more transistors on the die and whatever, but they're not going to go faster. They're just going to be more of them.
Sure.
And so all of a sudden we're sort of at a point in history where we must care more about concurrent, or we cannot stick our heads in the sand any longer about
Sure.
concurrency and parallelism and whatever, because you know, it's not like this is a new problem. This has been looked at forever, and we've had lots of special purpose, high performance computing hardware, you know, but all of a sudden this is becoming a mainstream thing. You know, my grandmother's going to have 4 CPUs in her, you know, or like starting, well, practically starting this year, it's going to be hard to buy desktops and laptops that have just 1 CPU. I mean, you're still going to have it in mobile devices and whatever, but you know, mainstream PC hardware now is multi-core. And if we want to like ride the wave, we got to figure better programming models for that. And one of the things that's so interesting about functional programming, if you try to connect the two here, is that functional programming at the end of the day is about side effect free programming. It's about expressing things, if you will, as functions, that when you give them the right input, out comes the result. And the thing that's nice about functions is that, you know, if you have a huge data set that you're going to run these functions on, because you're not like imperatively going in, first I'm going to mutate or change the value of this array and this array or whatever. You know, with functional programs, you can just split up the data and run them in parallel, and then collect the results at the end, so to speak, because programmers write in a style that doesn't presuppose this going before this going before this, so to speak. And that is, in a sense, you know, the foundation of LINQ is a functional foundation. It's a functional way of expressing your transformations and your queries that you do on data. And this is why, you know, a project like P-LINQ, which is a parallel implementation of LINQ that we have, an incubation project for, is you know, you can write your code the same way, and we can actually take it and understand what you meant and devise a new way of executing it by splitting it out and running it in parallel and collecting results at the end, as opposed to running it in series, or as opposed to remoting it to some SQL server and executing it over there. We give you more flexibility in the execution infrastructure. You know, you say just the what, but not the how of the program.
And now, so what is the reason behind not being able to do that in a construct that seems to be imperative? So in other words, it's still kind of odd to use lambda expressions. It's for the typical C# developer. They're not used to dealing with strings inside of a function. You know, and that's an execute. So I'm just curious, like, if the language could abstract away that notion without forcing people to write in a functional
Well, the
context.
problem, take a thing like a query, right? So if you didn't have LINQ, how would you go write a query? Let's say that you have an array of products, okay, and products have categories, and now someone needs you to compute, you know, like the number of products in each category and the most expensive of those products. What would you do? Well, you could write, let's see, a for loop or 2 nested for loops and some if statements and populate it into a list, or maybe if you're smart, you put it into a dictionary and do lookups. But you're writing all this imperative code that like moves data around. And if you take that program, you know, that has 2 nested for loops and say a dictionary and some, you know, tests for whether the element is there, and if not, then new up an element and put it in, otherwise increment the counter, or, do you know what I mean? Let's say you then get the IL out of that, and now you take that IL, and now someone tells you, please execute this on 4 CPUs efficiently. You're going to scratch your head and go, I can't see the forest for the trees here anymore. Do you know what I mean? It's like, all I see is like jump to here and add 1 to that counter and new up an object, and it's gotten lost in translation to leverage off that same paradigm. Now, however, if you express it as a transformation, if you will, a query that transforms the output, where you put a group by operator and you say, I want to group it by this and sort it by that, and well, then we can actually at a higher level understand what goes on, and we could run that into a parallelizing, pipelining piece of infrastructure, because we're talking at a higher level where we can still reason about the operations that go on. They haven't been broken down to atomic operations where we no longer can see the context.
Okay.
So that's sort of why it's important. You know, you can't do. There's been this hope that we would just devise parallelizing compilers that would magically just compile your program with this wonderful parallelizing compiler, and poof, it would just, you know, run faster on parallel hardware. Well, unfortunately, that's not panning out. And it turns out that in order to get efficiency from concurrent programming from concurrent hardware, you have to write to some concurrent programming model, or in some programming model that allows us to be at a high enough level that we can reason about.
And the more processors you get, the more that's true.
Oh, yeah, absolutely.
So like
this
some
is
of the
just gonna,
automatic parallelizing compilers, they might work okay for a few processors, but if you look at the processor roadmaps,
right.
they're going to be many more than you could scale up with using those techniques. And so raising the abstraction level, as Peter was saying, is the key for enabling better execution infrastructure, better and smarter execution infrastructure.
But also,
Yeah. No, sorry. Go ahead.
yeah. So I think people often look at lambda expressions as something that's kind of something really advanced. But in some sense, there's a kind of very nice evolution from if you're passing an object around, you're really also doing a lambda expression in a much more heavyweight way. And if you look at delegates, like in V1 and V2, there you had to define a delegate type in advance and so on. And now we're kind of moving to where you kind of have this func type, and you can kind of define your kind of, a one method class on the fly that you can pass. So there's really an evolution that's very natural from a kind of very heavyweight nominal class to this kind of lambda expression that you can pass around. But conceptually, it's exactly the same. So I don't think that there's a real paradigm shift. It's just like making something that people do all the time much more lightweight. Removing all the noise. I often say it's like Dolby for the programmer. Right? It's like removing the noise.
Yeah, I think that another analogy there you could have is like just. I'm at least old enough to remember when object-oriented programming was new, at least new in the mainstream, and everybody was scratching their heads and, oh my God, these objects, they're going to kill my performance, or I don't know what it means, and there was all this fear, uncertainty, and doubts about object-oriented programming languages, right? But now everybody understands that it's just another tool, it's another style, and we've become comfortable with it. And to me, this is very much the same thing. It's just another way of structuring your code that you may have not thought about before. And then once you start structuring it that way, then all of a sudden new patterns, new ideas emerge, and just as we've seen in object-oriented programming, where we have all these patterns that we now recognize and even formalize into refactorings and whatever. And it's the same thing. It's just a different way of looking at the problem.
That's awesome. I mean, I guess what the feedback that could go back to the people that provide this feedback is simply that it's not about writing queries against data structures as much as it is enabling you to take advantage of the future of hardware, right? Getting you used to what you're going to have to do so that the programming, that the runtime can help you help yourself when you're targeting 80 cores.
Right.
So I think a lot of people are just too caught up with writing SQL statements inside of their code and not seeing sort of the bigger picture. And it could be because we haven't really advertised it and marketed it in that way, right? We market it as, hey, it's now you can program your data in an imperative language.
Yeah.
Well, it's interesting because the reason that the data one pops so much is that it's so common for people to do database programming. So like when we were first doing the LINQ presentations, Anders and I were talking about how to frame this and this kind of thing. And I said, well, you should just ask the audience how many people use data in their programs, or how many people do database programming. And of course, everybody laughs and they all raise their hands and they say, oh, of course. And then you kind of go on and show how dramatically better it can be. And because database programming is so central to what so many developers do, that becomes the kind of the dominant thing, even though there are so many more domains, whether it's parallel programming or XML or just data in your program that's not in a database where you can use that same expressive power. And what we're really doing with LINQ is we're arming the people who produce APIs with a better tool set for building APIs. And so actually a lot of the language innovation that we've done has kind of been about the boundary between the languages and the APIs. And so in V1, a lot of it was, well, what's in the common language specification so that everybody can use those constructs in their APIs. That was a central thing. We had another recurring meeting about that in that time frame to kind of formalize that. Mm-hmm. And then in V2, we were adding generics to the tool set. So if you're producing an API, if things are things that are expressed very well with that pattern, you can do that. And with V3, we're essentially adding some of these new building blocks of expression trees and lambda functions and a bunch of others, the 7 or 8 language features, and the kind of the composition of those, so that people can build link-enabled APIs, and that is an incredibly powerful lever, because there are many more groups and people and companies that are producing APIs that are producing languages, and to the extent that we can kind of harness that power and provide a better tool set so they can build more powerful and more expressive APIs, so that we don't have to build link to Amazon, we have to build the basic building blocks that are used to construct such a thing, or link to XML, or link to SQL, or link to objects. It's an incredibly powerful lever, but is an abstract lever, and so it can kind of be dominated by some of the domains that are quite important. Such as I'd say SQL's link to SQL is probably the most prominent. I think link to XML, with the growing importance of the XML technologies in developer solutions today, is probably in second place on that. But from a language perspective and from an innovation perspective, it's the family of them that's the important thing. 10 years from now, we'll look back and we won't think about it as being linked SQL. We'll think, maybe the parallel programming one, or maybe
I wouldn't be surprised. I wouldn't be surprised if
there may be 3 or 4 other ones that are more popular than some of the ones that we're building today.
Yeah.
I wouldn't say that for link to SQL, but I would say for the domains that are in play today, there will probably be 3 or 4 additional ones that are kind of a default part of the programmer's toolkit 10 years down the road.
Absolutely.
That's actually an interesting point. I was just thinking about the evolution of Link and actually all of C#. It's always, it's never been just the language that we've ever talked about. We've always talked about the whole programming experience, end to end, including the libraries and the runtime.
Yeah.
And even to a certain extent the IDE experience as well.
Right.
Whenever we've been designing, it's never just about the language.
And as a team, we tend to kibitz in like the libraries as well, right? So with generics, we implemented generics in C#. Well, actually, we leveraged some Microsoft research work, done by Don Syme and Andrew Kennedy. Got to give credit where credit is due, but we also worked very closely with the base class library team to build a list of T and dictionary of K, V and whatever, because those are like the seminal applications of generics, and we got to get those right. Do you know what I mean? And with Link, it's the same. Like Link to SQL is such an important API that we've actually built that as part of in the C# group.
Absolutely.
As part of this process, and it's the symbiosis of the two.
But also, it's also kind of linked to XML, right? That's kind of
same thing.
A big API where there was kind of slightly overlap. Anders and I with some others did that, and then of course the sequence operators that are just linked to objects. So I think Link is I think maybe the API service might be as big as the language changes that are kind of if you just add them up together, it's And again, these only could be done because of the language. So there's a very nice kind of multiplier effect between the two.
So now you guys, since you were born out of the CLR, you've helped evolve that, right? You see how people are actually using the language and expect things to run for them under the covers, and you work with that team specifically to help that piece of software evolve as well, I would imagine. In other words, you're not just some language that is CLS compliant. You actually work with the team.
Yeah, definitely during Whidbey with the whole generics edition, that was a huge change on both sides of the street. The CLR and the compilers, and also with some of the other features that we did rather late, like nullable, that involved both sides.
Is that you?
Nullable crisis.
Yeah, the nullable crisis. So definitely, but Link itself is being built on the Whidbey CLRs, so that's kind of decoupled a little bit. The CLR is innovating, of course, at the same time, but the CLR now is rich enough that we can go and build Link without having to go and ask for more features and evolve it additionally, which is kind of gratifying, on their side that they've got a great platform there that is flexible and
excellent.
Yeah, we do benefit so much, whether it's from the libraries or the CLR side, of kind of playing on the boundary between the languages and the APIs, or the languages and CLR, and even when people go on to do other things, we still do that. So project Sean's doing now has driven a bunch of feedback for the .NET framework that's going to make the .NET framework better. And it's kind of, there's a small enough group of people who are working on the projects that, and the mutual level of respect is high enough that we can kind of play on that boundary very effectively and really drive some excellence on both sides. That kind of that interplay improves both sides.
Outstanding. Well, hey, I mean, from cool to C# 3.0 to, I mean, you won the outstanding technical award. That's incredible. And congratulations. I mean, that's huge. From cool to C# to being among the most prestigious technical people at a very technically proficient company. Nice job, you guys.
All right, thank you.
Congratulations.
Yeah.
Thanks for your time.
Mhm.